Imagine that you have created an amazing chatbot for your organization for one of the functions that you have. Unfortunately, those functions, people from those functions have to go to remote places of India where internet is a little flaky. But the solution that you have built for them is essential, or in fact, it's a showstopper. If that solution doesn't work, their work stops. What do you do at that point of time? Welcome to small language models, or SLMs. And some of those SLMs can be embedded inside your mobile device or your edge devices as well. So in this video, we're going to look at what are SLMs, how they're different from large language models, when to use SLMs and when to use large language models. But before that, if you have not subscribed to TestMu AI's YouTube channel, I urge you to do so, because they have some amazing content around technology, testing and AI from some greatest creators across the world. Let's get started with this video. So large language models are basically built on a huge data set. Like sometimes imagine some of the models of ChatGPT today or Gemini today are like built on entire internet. Now the question that probably comes to our mind right now is that, does intelligence require size? And some of the myths that people probably have is that if the amount of data on which the model is trained on is massive scale, that model has to be more intelligent. But the reality is the competence is not decoupled from the data, right? Size of the data. So the small language models sometimes, because they are very, very specialist on doing certain tasks, can go beyond a large language model for that specific task. So imagine that, let's say, whenever I go to my daughter's and son's school, I really get lost because I'm not accustomed to that environment, but they go there every day. So for example, when I go there and let's say I want to find out a restroom, it takes me a hell lot of time. But for my kids, they just immediately know where it is, right? Now, coming back to this situation, a parent must be having a large amount of data on which their neurons are trained on. They have seen massive places. They can navigate massive places with ease. But it does not mean that the children who are actually on the four walls of the school or on the compound of the school, they can navigate that school better, because they are supposed to do that when they are in school. They are supposed to know where everything is. If someone gets hurt, where they have to go. If someone has to play during recess, where they have to go. So their knowledge is limited and they do it much faster. So if I take that analogy into the same thing of SLM versus LLMs, I think SLMs, in my opinion, has a lot of cases where we know exactly what needs to be done, and we can't afford to use something like a large language model. We can use an SLMs and get the same output out of it, right? So if I look at a roadmap now, what happened? So we started with something like a large language model, and there are a lot of large language model came up, but it did not come into the public before November 2022. So let's say GPT-3, which was, I think, trained on around 175 billion parameters. Then the next layer, where we tried to segregate the parameters, we started giving the weights a little bit more across the segregated words on which they're getting trained on, as a result of which they started to correlate the words a lot more with lot more intelligence. And when they predict the next word, it started to become a lot more accurate, right? Then we suddenly thought, what if we shrink it? What if instead of, let's say, a 175 billion parameter, what if we come down to something like a 13 billion parameter in, let's say, Mixtral, right? And we started to see that if we try to provide enough during the training phase, if we try to provide those weightage in a way so that that small amount of data is also good enough for them to predict the next word, for some use cases, they are amazing. They are actually getting par of the large language model as well. And we'll show about that. Well, like I'll try to show something about that as well, because the next thing is that benchmark. So when we created that SLM, the thing is we had to benchmark it, right? How are they performing against the large language models or against themselves? Because we kept on shrinking, and that's the evolution. So I think from 13 it became 3.2, 3.2. It became sometimes 1 million parameter. There are models available, but we have to benchmark it. And MMLU, or massive multilingual, massive multitasking language understanding, is one of those benchmarking, and we'll talk about it in a bit. And then we figured out, okay, now that we have small language models in our hand and we have large language models in our hand, how can we orchestrate these two better to cost money and the cost of serving these models as well? So again, one of the things before I proceed, I'd like to bring to the fact that one more analogy to give you a little bit more understanding about large language model and small language models. Imagine that large language model is a warehouse of food that is available for everybody, right? But the nutrition that you needs to be served on that bowl, right? And that bowl doesn't need that entire warehouse of food, right? And so a 1 trillion parameter, which is the warehouse, and the 7 billion parameter, the 1 trillion parameter warehouse, which is probably applicable for everybody, but the 7 billion parameter warehouse, the meal for you specifically might be enough for you, right? And this is the main understanding of SLMs when we actually come to understand which use case we should choose when we talk about SLMs. So quickly look at LLMs, and there are examples like Llama 3, which is around 400 billion plus, GPT-4, GPT 5.1 now. Typically when the scale is around 100 billion to 1 trillion plus, we say that it's a large language model. And the hardware required to basically train them or basically infer from them is hyperscale GPU clusters. They have massive memory and general purpose reasoning. What does massive memory mean is basically their context window. They can remember at one stretch. They can remember. In some of the other videos, we were talking about the context window of these models. So Gemini, for example, has 1 million. It can probably remember the entire Harry Potter book at one stretch. So they have that memory. Now the cost is exponential energy and compute, as I was saying. They are, to serve them, you need massive GPU clusters, and you have to make them running all the time. When it comes to SLMs, in this case, the challenges to LLMs, they are basically some examples is Mixtral 7B, Granite, XLM 1 billion. These are small language models. Phi 3 is also from Microsoft. Are examples of small language models. So typically from 300 million to 13 billion parameters, we call them small language models. Hardwares, CPUs sometimes can basically serve the quantized version of these models. Single GPUs are enough, and as I was saying, you can run them on edge devices. Capability, they are very specialized, they are very, very fast, and if you are using them for the right use case, they are very, very efficient. And again, advantage, runs locally, no clouds needed. You sometimes don't need internets to run them. So the video with which I started, maybe if we would have used small language models which are embedded into that in the mobile phone or the laptops of those people, it did not matter to them whether they are out of internet coverage or not. They still can go ahead and use that solution. Now coming to MMLU, Massive Multitask Language Understanding. What is this? It's basically a set of 15,000 plus questions which is created, and typically when let's say you go and try to do a random guesses of the answers that are provided for those 15,000 questions. On random guesses, you have a probability of getting around 25% right. Average human who is average smart can score 35% for those questions, which is basically 35% of those can be correct. And a domain expert or a cluster of domain experts sitting together, maybe at a certain point of time taking those exams, can do up to 90% correct answers for those. So that is the benchmarking, and to be useful, it was says that a model must beat the average human, which is basically 35% of the cases, right? Whenever we are trying to create a new language model. Now, the fun here is that when we started compressing smaller models, so Llama 1, so let's say here if you see, if we take a threshold of 60% in MMLU score, Llama 1, 65 billion parameter, which came around February 2023, has scored above 60%, right? But Llama 2, which was 34 billion parameters, scored more than 75%. Mistral 7B, which even got smaller, scored more than 83% of in this benchmarking. And 𝐸𝐿, which was 3 billion or lesser, which came out on March 2024, actually did around 88%. So we have seen that when we compress the amount of when we created the algorithms, even the shrinking actually did not make any difference in creation of in the intelligence of these models. So speed and sustainability are the primary aspects for which people actually choose small language models or SLMs. Now, let's go a little deeper into this, these two things, speed and sustainability, and why I say so is because they have faster inference, because they have to do a lot fewer operations than a large language model would do, because the complexity of the architectures, in some cases, let's say I take a large reasoning model, which is even more complex, where they have to actually iterate through the input and the output a lot more before it actually produces an output token for you to see the output, is very, very complex. So they have a very, very high latency when it comes to basically providing the output. Lower cost, fraction of GPU budget, and we spoke about it. Sometimes you can actually have some small language models downloaded into your browser itself and keep it in your browser cache, and always anytime when you're doing any browser action, you can actually take the benefits of those small language models. And sometimes they're brilliant. I've used them for specifically for browsers, and they are eco-friendly. You don't have to have those high GPU clusters running 24 hours to basically serve them. You can actually use them only when you want to. You use them only when you want to use them, and the rest of the time you can keep them hibernated. So the other aspect that I wanted to bring here is the data privacy, right? And the reason is, when you have a small language model, as I was saying before as well, it can stay in your device, so your data is not leaving it. There's a saying that the output is for you, then the data should stay with you, right? And this is a perfect use case where you actually, or perfect mindset for which you'll probably go for small language model. The privacy, data never leaves your device. It's offline. You don't need an internet, right? For example, even in a browser, when I download, let's say, a small language model and try to create a chatbot around it, I don't need internet to basically talk to it. And security, ideal for medical and personal data. For example, let's say if someone wants to give their bank statement, last 5 years of bank statement, to Gemini, so that Gemini can suggest a better money management for that person. But you should never go ahead and do that, because it's your private data. And how amazing it would be if you actually have a small language model where you know that the data is not leaving your laptop or desktop, right? So when to use the LLMs, right? So a broad spectrum of coding, right, where you have reasoning across unfamiliar APIs. You want to understand the complexity of the business problem for which you have to actually go ahead and code. This is where you actually need large language models or large reasoning models, right? As well. When you have heavy documentation, let's say, I don't know, in the context of financial services, let's say all the RBI amendments that came till now, from the day RBI was actually created, and you want to create a massive knowledge base, and then you want to actually use a good LLM at the top of it, which can understand the question and actually work at the top of it. Of course, there is RAG, but let's say just in point of time also, as I was saying, that the context window of large language models is huge, right? And which means that at a given point of time, it can hold a large amount of data to understand your question and respond to your question better. When you have more complex and nuanced, like for example, let's say translations and idioms, where you wanted to basically come up with better answers, right? Better translation from one language to other, then the large language models are a better choice. The fourth point are discovery, where you have open-ended reasoning tasks. For example, let's say bioresearchers, right? Or in cases of financial industries, maybe something like where you want to understand strategies around cross-selling of your products. You probably need a large language model or a large reasoning model. When to use small language models? Robotics, and I'll come to this robotics in a bit, but let me finish summarization. When you have small things, let's say there is a daily dashboard for every employees or every students that are available, and you want to quickly summarize those to the teacher or the manager, so that they can support them better. And you know you are not going beyond 1 pages, so that is perfect use case for small language models. When you want to have on device, right? Let's say an Apple Watch, you want to have a small language model embedded into your smartwatch, right? And you want to use that language model to basically get better insights from your workouts or something like that. So function calling, where it beats larger models to specific API tasks, because when you have set of functions, you don't need high reasoning models to basically understand which function to call. So it was proven that they have done better. Coding assistance, I think matching performance at 2x efficiency. Now, when I say coding, I did not here I don't mean the coding which is a more complex coding. So more complex coding where you have business criticality, obviously you have you can actually you have to use a large language model. But for some of the codings where let's say you are trying to write sorting algorithms or something like that, you can definitely use something like a 𝐸𝐴 or something smaller model like that. Enterprise chatbot, if you want to fine tune a model, you always take a small language model, right? Because then it get contextualized information about the use case for which it is built. And summarization, as I was saying before. Now, when it comes to robotics, robots cannot afford cloud latency, right? You need to have, it will be a combination. So all the humanoids are being built in today's world have a combination of cloud as well as on physical device AI models. And when it comes to SLMs, there are SLMs which are multi-model as well, which can see, hear and act capabilities locally in those humanoids. So it is a perfect example where it moves from data center to the physical world, where we can actually embed these models into AI, into these robots. So another use case that comes to my mind is that agentic orchestration. Let's say you are creating an agentic solution for your organizations. So your boss agent, actually who is receiving the information from the user at the very beginning, has to be a large language model or large reasoning model to understand the task. But when it distributes into multiple agents, some of those agents can actually use small language models, because some of those tasks that are needed to be performed to actually achieve the final output may not be as complex, right? So this is where also you want to give it a thought. So I think I have covered most of the things that I wanted to say in this video to get you started about small language models. And if I just want to present you a cheat sheet again with when to go big and when to stay small. Is basically when you have massive GPU budget, your complexity is higher for your use cases, you go for LLMs. When your privacy is non-negotiable, most of the time you go for SLMs. When you need open-ended discovery, use cases like drug discovery or something like that, definitely you have to use LLMs. But when you need latency which is less than 100 milliseconds, obviously you have to go for small language models. In use cases where your context matters the most than the speed, you go for large language models. But when it is not the case, then you go for SLMs. When you have defined tasks, RAG, you want to classify things quickly, you go for small language models. When you want to build something that is general purpose, you go for large language models. When you want to build something offline or very specific task oriented, you go for small language models. So that's it for the video, and I hope it gives you a good understanding to get started and start thinking about how do you identify the language model for your use case. But I want to leave you with this, that you should go big but stay small, and the best AI model is the one that fits your use case. Thank you so much for your time, and I'll see you in the next video.